This is a continuation of the Chapter 11 review with Problem 12. In Problem 12, we're again finding the area of a regular polygon. In this case, we have a regular nonagon because there's 9 sides. And they give us some different information than they gave us in the first piece. So let's get started and try to take a look at what we've got here. As usual, what I'm going to do is I'm going to draw in this triangle. But I'm going to do it down here just so that I have more space to work with. So there's my triangle. I'm going to draw in my apothem and put in what I know. This value from the center to a vertex is the radius, so that's 7.6. And one of the side lengths, the base, is 5.2. So I know this is 5.2, which makes this thing half of 5.2, 2.6. Now, I can go ahead, and because this is a right triangle, I can use Pythagorean theorem to find the height. Let's just write in A for apothem, and we know that A squared plus 2.6 squared equals 7.6 squared. A squared equals 7.6 squared minus 2.6 squared. Take the square root of both sides, and A is going to be approximately 7.14. Now, I'm going to store that value. I'm circling it to show that I have stored this whole thing. I'm just going to use this as a placeholder, but there are several decimal places out here that I don't want to lose, so I'm storing those in my calculator. And I circle the A to indicate that I've stored them in location A on my calculator. If you don't have a location A, then I would recommend that you write down the number. So if you have 3 memory locations and you've stored it in memory location 1, that you would put a 1 with a circle over it, or some indication of the fact that you stored this variable in some location on your calculator so you don't forget it. Just a little precaution. Alright, now that we have our apothem, we can go ahead and start with our formula. The area of a regular polygon is 1/2 pa. Perimeter is going to be 5.2 times 9. So that's 1/2 5.2 times 9. That gives me my perimeter, and my apothem is 7.14. And again, I'm not going to use 7.14. I'm going to use the value that I've stored away. So I can just go ahead at this point, plug these into my calculator, and get my final result, which is going to be approximately 167.1. All right. Well, that was a relatively easy problem compared to the first one. Let's move on to problem 13 and see what we have there. But first, I'm going to go ahead and clear the board. And now for problem 13, we have the radius and we have the apothem. So in this case, it's actually the easiest of the 3, because now that's all I have to do is find this guy, this side length, and I can find my perimeter. Let's go ahead with that. We're going to use Pythagorean theorem. We'll call this side x. So x squared plus 3.3 squared equals 4 squared. X squared equals 4 squared minus 3.3 squared. Take the square root of both sides, and x is approximately 2.26. Again, I'm going to store this value because there's several decimal places I don't want to lose. Now, our area, again, is 1/2 perimeter times apothem. My perimeter is going to be made up of this side length times 2, because this side, each side of the polygon, is going to be twice the length of this piece. Because remember, this triangle is an isosceles triangle, and so this little triangle and this little triangle are congruent, which makes this side congruent to this side. So the perimeter is going to be 2x 2 times this length times the number of sides, which is 1, 2, 3, 4, 5. All right. And that comes out to about 22.6. Again, I'm going to store this value in my calculator. And my calculator, I have an TI-83, so I have 26 letters that I can use. If you don't, you'll have to come up with some creative way to store these values if you wish to store them. All right, now I have my perimeter, and I have my apothem, which is this leg. So we were going to go ahead and solve the problem because we have P here, we have A here, and that gives us 1/2 perimeter from memory, from the memory of the calculator, times 3.3, which gives us an area of approximately 37.3. All right. Again, fairly straightforward problem, but if you use your tools. Please notice the organization of work. Try to organize your work in a fashion that's easy for you to understand. Try not to spread things all over a 10-acre lot so you can't find what you're looking for. Come up with some logical scheme of how you want to organize your work, because a lot of times in these more complex multi-step problems, the organization of the work is at least as important as the computations themselves. All right, let's move on to problem 14. In problem 14, we're going to find the area of the composite figure. That means find the area of this shape and the area of this shape. That's going to require a bit of analysis, so let's go ahead and get started here. All right, now this, it looks like a trapezoid. We have one pair of parallel sides, and so we can find the area of that trapezoid simply. So let's call this area of the trapezoid is 1/2 the height. The height is 7, so 1/2 height times base 1 plus base 2, 9 plus 19. So that gives us the area of the trapezoid. Now, to find the area of this guy. This is clearly a kite. We have two pairs of opposite congruent sides, or I should say consecutive congruent sides. And we need to have, we've got this piece, that's 14 inches, that was given to us. We're going to have to calculate this piece because the area of our trapezoid is 1/2 D1 D2. Well, if this whole thing is 27 and this whole thing is 19, then that makes this piece 8. So let's go ahead and write that in. So this piece here, from here to here, is 8. And now we need to find this piece. So to find that, we have 19 and 9. This distance from here to here is going to be 19 minus this distance. 19 minus 9 gives us, let's see how we can write this. This 14 goes to this, and this distance from here to here is going to be 10. Now we have this diagonal. So we should be in a good shape to go ahead and calculate our area. Down here I'm going to write area of kite is 1/2 D1, which is going to be 18, D2, which is 14. And when we add those together, the area of our composite is area of the trapezoid plus area of the kite, which is equal to this plus this. Area of the trapezoid is 98. Area of the kite is 126, and the composite area is 98 plus 126, which is 224. So these types of problems aren't terribly difficult, but you need to be patient, take your time, and analyze what you have to determine how to find the areas. Of course, the basic element is you have to know the formulas for the areas of all your different shapes. All right, let's move on to 15, and I'm going to go ahead and clear the board first. And looking at 15, it appears that we have a parallelogram. This is not part of the composite figure. It's just this shaded region in this. This is just information to tell us what the height of this parallelogram is. This is a sector of a circle, and it's telling us that this angle is 223 degrees, and these radii are congruent, which tells us that this is a circular sector. All right, well, to start off with, the easiest one would be the area of the parallelogram. So let's call that area of the parallelogram, which is, area of parallelogram is just base times height. The base is 8, the height is 4. So base times height, which is 8 times 4, which is 32. Now we have to do the area of this sector. And in order to find the area of this sector, we're clearly going to need the radius of this circle. Well, if you sit and analyze it, they kind of gave it to us because right here, this distance from this vertex to here is 5. If the whole base, if this whole thing is 8, then 8 minus 5 gives us a length of 3 here. So this value is 3. We can go ahead and write that in. That's 3 there as our radius. Okay. And now let's go ahead and calculate the area of our sector. As usual, area of the sector is 2. Area of the circle as central angle is 360. Area of the sector is 2 pi r, the r is 3 squared, as central angle 223 is 360. So the area of our sector is just pi, 3 squared is 9, so pi 9 times 223 over 360, which gives us approximately 17.51. And I'm going to store that in location A because, again, I have lots of memory locations here. I have lots of decimals that I want to keep. So our composite area is area of the parallelogram plus the area of the sector, which is going to be 32 plus this value, actually the value stored, which gives us approximately 49.51. Again, not too hard if you take your time, analyze what you've got, and work out the formulas. Well, that'll wrap things up for this video, and we will tackle problem 16 in the next part. And I will talk to you then.